I'm going to talk to you today about my research, which is actually strangely similar to apps, using metals. And we all know what metals are. There are several metals that go on the table, but there are some that are very good for use as catalysts in chemical processes, namely rhodium, pretty good, platinum, indium, palladium, and ruthenium. These are probably, in my opinion, the 5 most useful metals for catalysts. Now, they're obviously metals, they're quite scarce, we mine them out of the ground and they're a finite resource, so we need to use them efficiently. And this comes down to the way we do a chemical process. So a traditional chemical process is a bit like making a cup of coffee. You have a cafetiere. And what you do is you put your catalyst in your cafetiere, you add your water, or your solvent. In this case it's not hot, but you would normally heat it, and you stir it up a bit. You put your lid on, and you leave it a while, and you do your reaction. And at the end of the reaction, what any synthetic chemist will tell you is that most of your energy goes into separations. So in a batch process, you then need to separate out your catalyst, and then you can achieve your product at the end of it. An alternative way of doing this, and a much more efficient way, is what's called a continuous flow process. So you quickly take your catalyst out of your batch reaction, and you immobilise them in some sort of column or tube. In this case, I'm using a funnel. And then what you do, a bit like if we go back to the coffee analogy and use an espresso machine, you then just pour your chemical, or whatever you want to do, through your catalysts into your reaction vessel. And hopefully they don't float out. So this is called a continuous flow process. And not only can we have one catalyst in this, we can then link several different steps together. So for example, we can have a ruthenium catalyst, and then we can have an indium catalyst, and then we can have a platinum catalyst, all linked in series in the same idea, and we can do several different steps in one go. And this is a much more efficient way of using metals and doing chemical reactions.